I'm Bob O'Hare. I'm the VP of the storage product line. So combined with Joe Amato, I'm going to run through our VSP storage offering. So I'll give you kind of an idea of what we offer today in our storage platform. Joe is going to deep dive into more of the technical details. I'm just going to kind of give you the upfront, how we package the platforms, what are the models and such. So we are focused on flash in our VSP platform. That is our major emphasis. However, we do offer what we call hybrid models. So we do offer what we have as our flash module. We have solid state support, and we do support HDDs. We have considerable advantage from a scale perspective. Our cloud integration gets into the REST API stuff, so not only in all of the software that you already heard about or different solutions today. In May, we introduced our first platform that had an embedded PF REST API. So along that kind of standard, everything we do must have a REST-based API, right? So we want to be very integration friendly. We weren't always that way. So in 2015, we kind of took it on to become much more of an integration friendly company. We do have our 100% uptime guarantee across all of our platforms, both hybrid and flash. So that's something that is significant. And then you already heard about the predictive analytics capabilities that we have. We did just introduce flat service pricing. So on our platforms today, customers have a more predictable support cost on our platforms in what we call flat service, or what the industry calls a flat service model, where typically in the past you had a warranty period and then you had the year A and year B kicker for customers where they got that big maintenance bill after the warranty expired on the platforms. That's not the case anymore. It's a little bit more predicted.
Free controller upgrades?
Not yet, no. So guaranteed efficiency, we introduced a total efficiency guarantee. Not only takes into account our dedupe and compression capabilities, but also takes into our thin provisioning and snapshotting capabilities to give you a total platform efficiency. And we do offer a guarantee around that. If you go through the program to let us analyze some of the data to give you a target total efficiency, we then do guarantee that for you. So, from a model offering perspective, the all-flash line starts at the introductory F350 all the way up to our high-end enterprise class, which is the F1500. These models here were just refreshed, or these are new as of May 7th or 8th, supporting both at the low end only solid-state drives. At the higher-end models, both our flash modules and SSDs are supported. So we're taking on much more. In the past, we were solely supporting FMDs. We now support more commodity capabilities and our proprietary flash.
Sorry, I've got to ask why. Because the FMDs were a big deal. That's got the onboard compression. If you buy the, stop me, shout if I say something wrong. And if you use if you go for the SSDs, you don't get the compression. So
That's true.
Why are you offering the SSDs?
So a couple of reasons. We haven't moved away from the FMDs. In fact, in July, we will introduce self-encrypting and compressing FMDs. So
those are going to be third-party self-encrypting?
No, those are our FMDs will introduce encrypting and compression for the 1500 model.
So for those of us that don't speak storage, what's FMD?
Flash module drive.
It's a separate
Custom
proprietary
flash drive.
SSD.
Proprietary flash drive.
That's our proprietary flash device.
SSD with extra unicorns and rainbow.
Gotcha.
But so why did you introduce when the all-flash VSP USB came out? It was FMDs only, I believe.
Yes.
So why have you added this option to start using SSDs?
So we want to have much more of a dual vendor type strategy, so we don't get caught with any type of.
Well, the F series you're saying was all of them, but we've always had SSD offerings on VSP.
Yes.
Yeah. So we've always had a mix available in the platforms.
That's true, but we don't want to. We also want to be multi-vendor to address the flash supply. We've also made a lot of improvements in our controller-based compression and deduplication. Joe's going to get into the details on that one. So a lot has changed in the platform over time to allow us to consume commodity SSDs as well as our flash module.
Both 2.5-inch and 3.5-inch SSDs, or?
Somebody still makes 3.5-inch SSDs?
No, 2.5 only.
2.5.
Small form factor.
Okay.
Answer?
So, yeah, I'll get to that in a minute. From a hybrid perspective, right, the low end, we do also support HDDs and SSDs, and more into the higher end platforms, SSDs, FMDs, and HDDs are supported from a hybrid perspective. That allows us to do tiering, 3 tiers, flash and traditional for colder data goes down to traditional spinning disk. So the generation that we just introduced, the 1500 is still our high-end platform, but back in May, we refreshed down in what we call the mid-range, introduced the 900, 700, 370, and 350 models. Right. So those just went GA. They're all powered by what we call SVOS RF for resilient flash. And again, a lot of improvements to our dedupe and compression capabilities in that code base so that we can introduce and start consuming more SSDs. We will also be introducing support for 15 terabyte SSDs. So, from a packaging standpoint, we have implemented an appliance model, the way we sell the software associated with the platform. So there's no longer a separation of hardware and software. We've greatly simplified the order process. From a 900, 700 perspective, those are 4U chassis. Again, both or all the platforms have flat service pricing. The 370 and the 350 are 2U chassis offerings.
What exactly do you mean by flat service?
So flat service, traditionally you would buy a platform, you would get a warranty period, and then at the end of the warranty period, you would have to buy a big maintenance bill, or the customer would have to renew their maintenance. Traditionally,
Well, I always dealt with those other 3-letter guys, and you just bought maintenance, and the warranty was a meaningless thing because nobody ever had one that was under
so
maintenance.
that's flat service pricing. So you just buy maintenance.
There's a
Okay,
1500.
so
Go ahead.
so is this, a guarantee of maintenance at the same price for X years?
we're not going to stiff
Yeah.
you on the renewal. Is that what you
Exactly.
mean?
And what is X?
Yeah.
And
X
How
being
long?
how many years?
yeah, because
Through the
'cause-
lifespan of the platform.
Until end of life.
Yeah.
The 1500 supports.
What's the matter with that?
it's not a satisfying answer. If I buy a product today, then I want you to tell me that that product maintenance will be available for some period of time I can budget against, and the life of the product isn't something I can budget against.
7 years.
So,
Thank you.
Right? Get a question?
okay.
The 1500, does it have, you didn't mention what the size of that was. That's not a 4U appliance or anything like that. Is it got the old, USB 1000 kind of capabilities where you have,
You can do both scale up and scale out.
yeah, so it does all that, and it's got shared storage and shared cache and all that stuff. Yeah.
Yep.
It's all internal, kind of proprietary technology. Okay.
Okay. From the hybrid models, same thing, same packaging, same flat service pricing. There's really no difference between the G offering and the F offering, F being all flash. There's consistency across that from an offering perspective. So same things we just talked about for the F are applicable to the G.
And the flat service in hybrid is pretty unusual. I mean,
Correct.
people are coming around to that, but it's because there is a lot more comfort in the longevity and maintenance of flash devices. Being able to do that across both all flash or hybrid was something that's caught customers' attention.
So one thing I do need to note, and the difference between you have the G1500 and the F1500, that's the only platform that still has variances in the offering. So G1500, which is hybrid at that level, supporting SSDs, FMDs, and HDDs, That's still traditional warranty plus what we call year A, year B renewal, no flat service pricing. The software packaging is different. Everything else is in an appliance model, flat service pricing. Everything's consistent across all those models. So I know there's been a lot of discussion today around don't show me 3x, this or that. But nobody wants to introduce slower platforms. So in the interest of that, and early in this morning, somebody said, we still sell speeds and feeds. So speeds and feeds, obviously we introduced.
We showed the scale on the right.
Well, you said a 350 is 3 times faster than a 200.
Yes.
That's exactly right.
A relevance of some sort.
Yes.
Yeah.
So going all the way up to the 900 is introduced and allowed us to go higher into what you would want to call entry-level mid-range, or excuse me, entry-level enterprise, right? So it has much more capability than the 800 had. And then we are starting to work on and define what that refresh will be for the 1500 platform. So we can talk a little bit about that in the NDA session. So.
I'm sorry, can you go back to that? So a fully configured F1500, roughly 5 million IOPS kind of thing?
Yeah,
Yep.
4.8.
What queue depth, what latency, what block size?
No. Start
Without them.
We are behind, Tim.
Yeah, shut up.
And those are my usual
Oh,
questions.
shut up. Yeah.
Over a beer.
And that's with a single VSD pair? Is that what that said?
Fully
At the bottom of that,
populated,
it said-
5
Fully pop is 8 VSD pairs.
So the 5
So to get to almost
6
5 million IOPS, you're at fully populated.
Two chassis, fully loaded, all the cache, all the.
Right, gotcha.
So from an integration standpoint, we've also introduced a persistent storage adapter for containers. That's available for free. You can download it from the website. I validated it again today. That's out there for integration into containers. That gets into how we're trying to be more integration friendly. Again, taking on the API approach, embedding a REST-based API in the new mid-range boxes. But we also have something that's called Configuration Manager REST.
Excuse me, so mainframe support FICON, is that only available on the top end? Or
1500 only. 1500.
hybrid as well as flash all?
Yeah.
Yes. Yeah. So, but that gets into what we're utilizing as well now for our OpenStack integration. The Configuration Manager REST API allows us to span across all of our platforms, both legacy and new. So traditionally, a lot of vendors, including us, would take their Cinder interfaces and code them to specific APIs on each platform. Those APIs could be different per platform, and therefore it took us longer periods of time, or we did not fully support every platform with our Cinder driver, right? We've simplified that greatly by adopting CM REST, spans across all of our supported platforms, both legacy, so VSP, VSP 1000, the whole former 800, 600, 400, 200, all the new boxes, all are supported by CM REST. The advantage of that is it's a consistent interface. It doesn't change from platform to platform, and it speeds up our agility of development, like things for OpenStack in the Cinder driver perspective. Also, from a simplification standpoint, the new 350 and the 370 new models, if you're not familiar with our storage, they come with a service processor, SVP as we call it. You can do that in a hardware or software version. With these new platforms, you can go completely SVP-less. So a key thing here is with the REST-based API that's embedded, and with the capability, there is now a new interface embedded on the platform as well. A customer can power up that box, not have to install any other piece of software, and configure that platform and deploy that platform. So much more simpler installation, configuration, no need for any external management tool to deploy that platform. You look perplexed.
No, I'm not worried about it. It sounds like a nice improvement, but not something that we need to slow things down for.
Good for partners.
Good for what?
Good for partners.
Yeah.
Partners like the idea that they don't have to have folks to go out and install it. So it also improves the setup time by basically 1/4 of what it was. So when the array ships in that configuration, it's, available to the customer for productive use maybe within an hour, where it used to be 4 hours, that kind of thing. So that's kind of a value proposition for that.
So here I'm going to turn it over to Joe. He'll go into more of the technical details around the improvements to what we call active data reduction, which is the compression and deduplication, and other factors of the arrays.
Thanks. Hi. I guess we're nearing the end. We're nearing the finish line, so I guess that's good. I'll try to pick up some time. My name is Joe Amato. I work for Bob, and I own all the technical PMs that deal with the core storage platforms and the program products, which are all of the stuff that runs basically in the arrays. What I'm going to talk about is a little bit more about how we're doing things and why we were doing things. So, for example, one thing I want to mention on this slide is that the metrics. Yeah, we increased the platforms and we increased cores and cache, and that was good for scalability. But the metric that we're really starting to look at is IOPS per core. And IOPS per core is now a more objective measurement of the actual code level enhancements that we're doing. And I'm going to show you a couple of those. Another thing we had to do was change the memory management model. So this is why SVOS became SVOS RF. The key there is we wanted to move more towards an SDS type of approach. The question was asked earlier about why are we doing more with SSDs. The answer is we want to be able to do hardware where hardware provides value, and that's a good thing. But on the other hand, you want to be able to have a software offering that doesn't require proprietary hardware. So you want to be able to address all those spaces, okay? So that's why we've made some investments there, and I'll take you through what some of those are. The other thing in the memory model was that when we first came out with the mid-range platform, every one of the models that were in the previous line had a separate build of the OS, a static memory setup that reserved certain tables for metadata. Now I'm talking about metadata not for the adaptive data reduction and the deduplication. I'm talking about metadata for your LDEV tables, your mapping tables, all of that kind of stuff. All of that was static. Now what we're able to do in this configuration is at least 3 of the models were able to share a single memory build. And so that's something that allows you to get a lot better scalability, where now the high end of the range supports the same addressability for snapshots, logical devices, and so on that the big brother, the G1500, F1500 support. So these are some of the things that you see as kind of the marketing, what was the result. I'm going to take you through some of the things that are under the covers about how we got there. I'll take you through some of the adaptive data reduction enhancements as well. So in the interest of time, I'm just going to skip a couple of slides here and get to some of the meat. So one of the things that we had in the old architecture was you see that there's an array. It's a dual controller array, so where it says controller 1, controller 2. We had, for example, on the higher models, 2 CPUs on the controller, but we blocked them off from a core management standpoint. These MPUs stand for multi-processing units. That's the level that you have to administer LDEV ownership for. So one of the challenges that we observed, again, as we're trying to improve this, is that when you did this, you assigned an LDEV to a multiprocessor unit, it wasn't able, the tasks that ran here were not able to exploit all the cores. So one of the challenges is when you're trying to do I/O, you're trying to do any kind of operation, a copy operation, whatever, you're now limited for that LDEV, that volume, to only being able to use the amount of resources from a processing standpoint that are on that one management unit. We realized that this also takes more memory to be able to address. So in satisfying both this challenge, we said, well, on the right side, we now have 1 MPU per 2 processors. All of the cores can be addressed. Management is easier for the customer. The scalability and operations that you can operate on a single volume are much easier. This is an important distinction, because what we were getting before was you had 1 volume, and it was like, well, how come this 1 volume has a little bit of a challenge, and yet all the other volumes are fine. If you had an imbalance in I/O or I/O for a single volume that was really, really heavy, that became a challenge. We improved that. So basically, this started us down a path of memory improvement, processor management improvement. When we did that, we were also looking at the I/O redesign. And this I/O redesign is very, very important when you understand that infamous kind of topic about where we're going with NVMe. And we'll talk more about that, I think, in a later session. But the key thing here is that there's front end and back end. And in the previous architecture, we had to do 4 different hops of process handoffs between reading from the front end, doing the back end task for the RAID configuration, the drive access, the SAS back end. All of those things, these 4 hops, meant latency. So what was happening was you had shared memory, you had handoffs, you had to start up new tasks to deal with these things. That introduced latency. With direct command transfer, DCT, we've basically done what we call front end, back end integration. That reduced latency, and as you can see, we got down to 2 hops here. Now, so that was the second big enhancement. Now, this is a very, very important step when you talk about going from an architecture that had ASICs that were doing a lot of these functions. Because when we first did this in the mid-range platform, this is now all done in software. In the high end, a lot of these functions were done in ASICs, so the performance was better. So the more that we were able to reduce this, the more we bought back processor busy. We had more scalability. We were getting more overall scalability using and reducing performance.
So when you designed the thing on the left, presumably it was a decade, 2 decades ago, when there wasn't that much x86 power, and he had to use ASICs.
Right. Remember, SVOS started, okay? SVOS started in the high end only. Right? We then took SVOS and said, okay, we want to take SVOS on the high end, which had monolithic scalability, cache, processors, switching, ASICs, and we said we want to use a common OS so that we can have a common ease of use definition model, and we want to bring that level of ease of use and management and push it down the stack into the lower price points. The first time doing that was with the first wave of the mid-range platforms that you saw that came out in 2015. That's what got refreshed in this year on May 8th.
And those platforms, they had the same ASICs then?
No.
The ones in 2015, the mid-range platforms, they were...
The mid-range platform, no, the high-end platform has ASICs. These platforms have no ASICs, zero ASICs.
But the mid-range box...
Prior platform for mid-range.
Prior platform...
The ones you launched in 2015, did they have ASICs?
No, they had no ASICs. But what we did was a straight, basically, port of emulating the code that was on ASICs and did it in software. There was no code optimization.
Right.
Okay? So when you took out the ASICs and you put it in software, you know, connect the dots for yourself. You don't need me to do that for you, right? Okay, so that was the next thing. Now you start getting into the next wave of what's important about this. So once you had the DCT optimizes the path when you have front-end I/O that's going to a back-end device owned by the same processor. We call this straight-through I/O. Okay? Now, when you have to go to another processor, this is the previous system on the left. This is the new system on the right. So when you go across processor, you have inter-processor handoffs that have to happen. Basically, the front end happens here. This management unit owns that device out the back end. These little red, kind of arcs, that's overhead, okay? So the advantage from DCT is in straight through, you have overhead without DCT, and then you have additional overhead when you have to go cross controller. Now, this is extremely important because when you see all of the guys about what's the difference between active designs, active passive, or active standby designs, these are fundamentally different things. We've taken the strategy here of active designs. When you do this, you have to understand that you've got to manage the I/O and minimize the latency when you're going to balance and use all your resources that you're shipping to the customer and powering and cooling on their floor. But when we went to the single MPU per controller, the span of the DCT benefit got broader. That's what this indicates, because now you no longer have, you still have the cross-controller overhead, but you no longer have the cross-MP overhead on the same controller. Everything now on this controller is straight through. This was immediately a benefit when we do things like with our global active device, which was Alua intelligent, to be able to optimize and non-optimize I/O paths. So now you're able to effectively utilize that and get more consistent performance, scalable performance.
So a controller in your parlance is so you have a multi-controller storage system, is that?
The mid-range platforms are dual controller active
So there are
active
two
systems.
controllers active.
Correct.
And so when you say an MPU, in the prior instance, it would be within a controller, there were two segregated sections or multiple segregated sections within that controller that had front-end, back-end responsibilities.
Correct. Basically, yeah. It's just
And by going to a single MPU per controller, regardless of the number of cores in that controller,
you now can, your tasks, the things that you have, the jobs that you have to start, now have access to all the cores on that side. You have less memory management, because the other thing you also have to do when you have multiple MPs is you have to
Control all this
reserve
stuff for sure.
a core part of the management overhead. This was, I mean, this is just a cool thing we were working on for a couple of years. But the real thing that's really cool about this is where the direction's going when you talk about the enhancement that you have to start to do when you really want to exploit what is true end-to-end NVMe. Because everybody else is talking about what you get on the front end, what you get on the back end. The key is what are you going to do to optimize and connect the front end to the back end in the middle, okay? This is the level of research and investment that we've been doing here, okay? Any questions? We're moving on. I have 13 minutes, which is very good. Just to indicate a real-world sample, we've done a lot of testing, and everybody does simulated workload kinds of testings, certain block sizes, certain cache hit ratios, and the feedback was primarily from his boss, who's my boss's boss, said, I want to see real-world stuff, so you got to do real-world testing.
You
So we did-
realize this is being recorded.
I understand. Erie, I love you. If you
And
see it-
my boss is watching.
It's okay. I love him too. Thank you. I love you all on the phone. I'm from New York. Italian. We love everybody. Anyway, the key thing here is that this was a real VMware ESX test, 64 VMs. This was really running real workloads. There was a migration aspect of this, and we'll talk about enhancements that we did with ADR and data reduction to specifically exploit vMotion as a way to get the data into the box and be able to process that with inline intelligence. But you can see here that we did this testing here. We got 176% performance improvement. Now, this was all the things that we capped. We said no matter what you're doing, we just drew a line and said 1 millisecond. If it's more than 1 millisecond past the knee in the curve, we didn't report those numbers. We said, 1 millisecond flash array. That's what we want to draw the high-end measurement point when we do the scalability numbers. Okay. The key thing about data reduction, we offer a bunch of different options, and they have, good advantages, better advantages, best advantages, right? Kind of starting from the left, the flash module, FMD, the proprietary module, has compression on the drive. There's no software doing the compression, but it doesn't have dedupe. So it's good for database stuff. You get your, 1.7 to 2.1 kind of compression ratios, but you're not going to get any dedupe kind of really, really dense, data reduction estimates. So it's always on. It was at the media level, top of the line type of support. It's available on the top models in the product line. It's also still available, obviously, on the high end. The next one is you want to do compression only in software. Now, the compression only in software gives you, I can use less expensive SSDs. I can still get good latency, but what I'm giving up in that one is I'm giving up the scalability in terms of number of IOPS. So I can get the same type of support without having to have the proprietary modules. This is an important thing when somebody comes and talks to you about SDS and where we're going with that. So keep that in mind. The next one is a kind of a hybrid. I want to have the FMD media to offload the compression and take the cycles away from the processors to do the compression, but I still want to add dedupe on top of that. That's the third column here. And then the last one is obviously the entire software model. Dedupe and compression, all in software. All of these options are offered in the platform, okay? What we did with this one, when we first came out with dedupe and compression, all of the dedupe was post-process. All of it was post-process. We came out with some enhancements along the way that said for sequential, 256K block sizes will let you do inline and avoid the post-process. The first challenge with that was vMotion of VMware needed a 64K block size. The other thing was it wasn't truly sequential. So if you weren't really, really sequential, it didn't treat like sequential and you fell back to post-process. So we softened this as an enhancement in the current release that allowed some, what we call large block random, to be able to be treated as inline as well. So now this is truly adaptive, it's truly looking at the workload, and it's truly balancing the benefit of dedupe and compression, getting to the capacity saving function, realizing that earlier in the lifespan of the array. And what we did here was we called this thing roughly sequential writes. And what roughly sequential writes meant, if we had 16 contiguous LBA slot sizes in cache, and 8 or more of them had hits, we then said it's close enough to be treated as inline, and that softened it. So what we basically did was we expanded the scope for how we could process inline dedupe and compression.
So I've got to ask you a tough question,
Sure.
or what I think is you're one of the very few tier one vendors that is not doing inline dedupe. That hasn't yet got inline.
No, I just said we're doing inline dedupe.
Only if the block size is above 256K, which is
64K. Did I say that here? Actually, we adjusted it to 64K. So if it's 64K or higher, which can also include what we call large block random. Some of the backup utilities we found use what's large block random. So we wanted to be able to use backup and restore and also treat that as inline. So this is not totally dedupe inline, because the random, if you turn random small block size on for inline with processor, the overhead and the latency would just be, not optimal, right? So what you want to do is take the process on the sequential, large block random, and avoid the post-processing for those kind of workloads.
And you're talking about both dedupe and software compression.
Yes.
Oh, this whole conversation applies.
Software compression only is always inline.
Yeah, that's always.
Software compression is always inline. It's when you have we don't support dedupe only. So it's when you have software compression and dedupe. That had to be the change. Also, if you mixed the compression on the drive with dedupe, anytime you turned on dedupe, it became a factor.
What about the bottom? Oh, I suppose there are two bottom lines. One is what data reduction ratio are you getting, and the other is what's the performance. Performance is impossible to quantify. We've already established that because we're equating IELTS.
The dedupe compression ratios that you get are a function of the customer's data.
Yeah.
So, there's no way to get around that. So, you either sample that in some way,
We do see
shape,
other
or form.
vendors quoting average ratios across their entire customer base.
Those vendors still go back and run some type of sample.
Yeah, and they include clones.
And then they have to
Everyone's
additionally
cheating.
true up and different things like that. So,
We should talk more on this
Yeah.
topic at drinks.
Yep.
Okay?
I mean, everybody, to get any type of guarantee, you have to do sampling of the data.
Oh yeah, no. What I meant was, what I was saying was
They'll
there are
quote
vendors,
averages, right?
we'll say across our entire customer base, we are seeing an average ratio of 4.88 to 1. But I've just remembered that they're including clones and provisioning.
What you guys
we'll
talk
see.
about over drinks confuses me. Like there's LeBron versus Jordan.
Yeah.
Jordan.
You guys are talking about dedupe.
Yeah. No,
Hey, I
well,
can't
that's
help
what
it,
they
man.
think we're going to talk.
Storage guy. I will talk about
5
IO
minutes
flows
left.
and deduplication all day long.
So can we postpone that? We can move on. Okay,
So my problem with
okay, go, sorry.
offline deduplication in primary storage,
Offline?
delayed.
Background.
Background,
Post-process.
post-process,
Post-process.
whatever term you wish to use.
Okay.
My problem with post-process deduplication in primary storage is how long before you're deduplicated. Because if that's days,
No.
capacity planning.
That's another enhancement we made. So initially, we started out in the first release, we said it's got to be an hour before we even consider, if the data has to be untouched in the temporary area for an hour to be on the queue to actually post-process. Because if you keep hitting it, we left it there. By the way, one of the other companies.
So my busy data never dedupes.
So active data would never dedupe. That's right. And what you'll find if you look at some of the white papers from our competitors that are doing this, you'll see that some of them have similar treatment of active data.
I'm not happy with them either.
Well, you're not going to be happy sometimes.
Yeah, and the problem.
All right?
Sometimes.
There you go. See, I'm not alone.
Oh,
Anyway,
come on, Ben, you saw me happy once.
Okay, another question? Or
Well, no, the problem is capacity planning. If I don't know, if I'm loading up the system because I just bought it and I'm ingesting a huge amount of data, figuring out how much space I have free if you're not deduplicating in real time.
So
becomes
the
really
good
difficult.
part is we've spent a lot of time also with monitoring tools. They could be better, but we now have much better standards about what the post-process rate is. We've reduced the amount of period that you have to wait to like 10 minutes now before you start saying something has to be post-process. And by optimizing with the inline, the ingest portion, precisely the point that you're describing, that ingest portion is now handled inline with deduplication. And that's optional. It defaults to on, but you can in fact turn inline processing off if you determine that you have some workload that later the sequential needs to have a faster throughput and not absorb the overhead. So we can optimize for the ingest phase and also then tune later for performance after you get to steady state. A little more happy. Almost, I got an
It's a pretty good thing.
That's a win. Is that a win? That's a win. All right, I got a win. Good. Right coalescing. How am I doing? I see it. I see it. I see it. I could talk fast. We took a little bit of heat from what was going on the back end. Before, what you had here was all of the back end IOPS, we do 8K chunk size. So all of the 8K chunks became direct back ends. Obviously, dedupes you didn't have to write to the back end, but whatever had to be written to the back end, we were doing individual IOs to the back end. With the new release, we now aggregate those, coalesce those up to a 256K, and do single IO out to the back end. So this is right coalescing. And now the trade-off is, you have to watch a little bit about buildup in cache, which you don't normally get. But the point is, you're also dealing with a lot more efficiency and also buying back scale, because now you don't have to use all of those IOPS and all of those task transitions that we were talking about earlier. All those things go away because you're doing the coalescing of the writes. Okay?
Do you have non-volatile memory?
Yes, non-volatile memory, battery backed up, okay? A couple of other things. I think I'm nearing the end. 1 minute left. Garbage collection. You got to do some things with garbage collection. Everybody has this issue. There's two strategies. You need both of them. One is make less garbage. What this does is make less garbage. So what we do here is we now say if the data is equal to or less than the previous block, we just overwrite it. Before, we used to just write it and then have garbage to collect, okay? That meant that you had to do more garbage collection, which means more reclaim, which means more pool build, okay? I'm going to stop here and move in the interest of time. I think this is the last slide, 26 seconds. The key thing here is program product combinations, okay? Everybody is talking about what their performance is and what their latency is. What we heard from our customers is, I'm buying your array, I'm doing all this great data protection that you heard from John earlier with HDID, and you heard about global active device and all of our disaster recovery and high availability options. Problem is, when you turn it on and you have to do it with data reduction involved, there was a hit, okay? And what this is showing is you have two factors of the hit: initial and resync copy, which is the initialization or return to normal from, let's say, a disaster recovery test, something like that. And then you have your normal update write. What we basically got to is the point that the old model's baseline, which was the blue, when you turned on a data reduction function, went to the purple line. So 24 became 47, 20 became 100. Now we're at the point where the most stressful all software dedupe compression with dedupe and compression is basically about where the baseline of the previous model was with no ADR on. So now we got to the point where a customer could upgrade from the old model to the new model. They had their data reduction policy, and they're not giving up really anything on throughput or their disaster recovery function. This is an important slide. We were talking about, what is your latency? This is our simplex latency. This is no NVMe. This is just what we've got. This is 100% random write hit, okay? And what we're looking at here is what is that worst case, most stressful for the replication product? And what you can see here is we've got very, very flat latency, okay? The difference is once you turn that on and you put a replication product on it, the replication product is going to be more of a factor than the data reduction. Sorry?
So this is sync wrap, yeah?
Sync wrap.
This is bidirectional synchronous
But only your
replication.
European customers are going to be using synchronous replication for.
Lot in APAC also.
Yeah, okay.
Okay. The key point I want to make on this slide is this is with dedupe and compression, and the point is, if you look at the scalability and you say, well, gee, I was looking at the array and I want 1 millisecond of response time, you can say, it doesn't matter what type of configuration that you pick, encryption, compression, FMD, once you turn on replication, this is the thing that I want to see the competitors do, okay? I never see anything from a competitor that says, where's the real world use case and what does their performance look like once they turn on a DR or an HA type of configuration.